Hey there everybody. So what we're going to do in this video is we're going to talk about a concept called circumcenter, and we're going to talk about how we find one. So what is the circumcenter of a triangle? A circumcenter of a triangle is the point where all three perpendicular bisectors intersect. It's called a point of concurrency. When we have more than one line intersecting, that's called a point of concurrency. So a circumcenter is a point of concurrency, and it's called point of concurrency because more than two lines intersect. Concurrent, there we go. Had trouble spelling it. So on this circle, the circumcenter is the point of concurrency where the three perpendicular bisectors of this triangle intersect. The circumcenter is the center of the circle that is circumscribed around the triangle. All right, so let's show that D is the circumcenter of triangle ABC. Now, to be a circumcenter, it needs to be on the perpendicular bisector. So what we're saying is this segment right here is a perpendicular bisector. So how am I going to show that it's a perpendicular bisector? Super glad you asked. I'm going to show it's a perpendicular bisector by saying, hey, bisect that side and make a right angle. Not only is that segment a perpendicular bisector, so is this segment. Notice they don't have to go to the sides. So that segment is also a perpendicular bisector to a side. So it's going to make a right angle, and it is going to cut this side in half. Lastly, my last segment, don't know why that happened. My last segment is also a perpendicular bisector. The segment inside, this one right there, is a perpendicular bisector. So again, side AB got cut in half, it was bisected, and we made a right angle. So this point right there, we're going to call it D because that's what it said in the problem, is a perpendicular bisector. And if we put in some other points just for fun, let's label this E, F, and G, E, F, and G. What we know is the length of AF equals the length of CF. We know the length of CG equals the length of BG. Notice I'm not putting the segment mark on top, so you know I'm talking length. And the length of BE equals the length of EA. Alrighty, and then that's point right there, point D, is the center of what we call a circumscribed circle, and we will take a look at that. We'll probably see that tomorrow in class. So is a circumcenter always inside the triangle? The answer is no. No, it's not. Depending on the type of triangle, and you are going to need to know this for your test, so I would write this down and maybe study this. The circumcenter can be inside the triangle, outside of the triangle, or on the triangle. Notice this is an acute triangle. If the triangle is acute, the circumcenter is always inside. If the triangle is a right triangle, what is going on? Oh, I see what's going on. Okay. If the triangle is a right triangle, then we are on the hypotenuse. The circumcenter of a right triangle is always on the hypotenuse. And if my triangle is obtuse, one of the angles is bigger than 90, then the circumcenter is outside the triangle. You need to know these relationships when we take our Unit 5 test, so make sure you jot them down and you understand. So circumcenters, the circumcenters, the point of concurrency for the perpendicular bisectors, can be inside the circle, or inside the triangle, on the triangle, or outside of the triangle. So why is a circumcenter special? A circumcenter is special because it is equidistant from the vertex of the triangle. So if I give you that triangle we looked at earlier, ABC, where D is the circumcenter, what I know is if I connect the vertex of the triangle, let's change that. I don't want this. Yeah, let's do blue. If I go from the corner, goodness, I'm going to get this. If I go from the corner of the triangle to D, corner of the triangle to D, corner of the triangle to D, all of those segments are congruent. From the corner to the circumcenter equals from the corner to the circumcenter equals from the corner to the circumcenter. Boom, boom, boom. And then a circumscribed circle. A circumscribed circle is a circle that has the circumcenter as the radius, or the center. The circumcenter, U, is the center of that circle, and it hits every corner of the triangle. The circumscribed circle goes around the triangle. Circumscribed. It's like circumscribing the globe. You go around. So when I'm looking at this, if you notice, segment UX, segment UZ, and segment VU are all radii of circle U. Okay, and what's really cool now is what we can do is any point on that circle is going to be equidistant from point U. So boom, that new segment I drew in is the same as every other radius because every radius is always the same. Alrighty, so if you have questions, make sure you jot them down and you come in and you ask your teacher for that extra help. You got to know a lot of the things that we put in this. As I've said, vocabulary is super important in this unit. Alrighty, Patriots, I hope you have a good one if you choose to, and we will see you when we see you.